Okay, so our goal is to graph the conic section represented by this equation. But first we have to figure out, what conic section this equation represents. So for that, we're gonna rewrite this equation in a form that we can recognize, and we're gonna use completing the square to help us. So the first step I would advise is to group the x terms and y terms together on the left side and to bring the constants to the right. So let's rewrite this as like 4x squared followed by plus 8x, then minus 8y squared, then minus 48y, and then we're going to add 100 to each side, so we'll get that equal to 100. Now we're going to factor out the 4 from the x squared term, so we'll have 4 times x squared plus 2x. And then for the y terms, we're going to factor out an 8. So we're going to have minus an 8 times a y squared plus 6y equal to 100. Now we're going to complete the square for each variable, so for the x variables and for the y variables. And for that, let's recall that we're going to have to add b over 2 squared to each group. So for the x terms, we'll have something like this. We'll have 4 times x squared plus 2x. And b will be 2, because that's the coefficient of x. So b over 2, or 2 over 2, will just be 1. So we're just going to add 1 squared to that group. Now for the y, we're going to have negative 8 times y squared plus 6y. And our b is going to be equal to 6. So b over 2 will be 6 over 2. 6 over 2 will be 3. So we're going to add 3 squared to that group. It's equal to 100. Now, let's be aware that we're going to need to add not just 1 squared and 3 squared. We're going to need to add 4 times 1 squared to the right side. And then negative 8 times a 3 squared to the right side. Be careful about that. Now the nice thing about completing the square is that this makes it easy to determine how it's going to be factored. This will just be equal to 4 times x plus 1 squared. That's the whole point of completing the square. It'll be x plus 1 squared. And then for the y terms, we'll have y plus 3 squared as their factored form. And on the right side, remember we're adding 4 plus 4 times 1. So we're adding 4 there, and then minus 8 times 9, so we're taking away 72. So we're having 100 plus 4, 104 minus 72. So 104 minus 72, and then we'll get 32 on the right side. And then we're going to divide by 32 because we want to make this equation equal to 1. So we're going to divide each group by 32. So we'll have 4 over 32. That becomes just 1 over 8. 8 over 32 is just 1/4. Is equal to 1. Now here we can see we have a horizontal hyperbola. I don't know why I wrote it that way, but horizontal hyperbola. the x terms came first, followed by the y terms, and this is minus, so that's usually how I go about figuring out if it's hyperbola and if it's horizontal, since x came first. Now, the center will be again at hk. So let me just rewrite the equation, the general equation for a hyperbola over here. So x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So center hk, so x plus 1 is the same as x minus -1, so h is -1, y minus k, or y minus -3, so k will be -3. So our center will be over here. And then our a squared is equal to 8. And our b squared is equal to 4. So then a will be the square root of 8, which will be about 2.83. And b will be the square root of 4, which will be 2. Now, these points or these values tell you how much to move from the center, either horizontally or vertically, and that's going to help you plot your co-vertices and vertices. So, since this is a horizontal hyperbola, the a values are going to help you figure out where your vertices are. So you're going to move horizontally 2.83 units from the center to the left and right. So like 1 to the 2.83, you'll have one vertice at about 1.83, comma -3, and the other one will be 2.83 units to the left of this. So 1, 2, so it'll be about -3.83. Comma -3 for that one. Now, the value of b is going to tell you how much to move up and down from the center. So you're going to move up 2 units, and then you're going to plot a point there, and then another point 2 units below the center. I actually went too far. I went 3 units. Yes, draw a line out. So that'll be at one of my co-vertices will be a -1, -1. My other one will be 2 units below the center, so 1, 2. That'll be a -1, -5. Now, the way I use this to guide my hyperbola is to draw a rectangle that goes through these points, so through the co-vertices and vertices. We get a rectangle looking something like this. And you're gonna have asymptotes on your hyperbola that'll go through the corners and through the center of this rectangular box, something like this. So you have one asymptote like that, draw a diagonal, and the other one like that. And then your actual hyperbola, the branches will be looking something like this. You're going to asymptotically approach these lines, so looking to the right like that. And It's not opening to the left like that. Something like that. There's your hyperbola.